So let me talk about it here. So as we have represented this in a matrix form, the y as x theta as well, like let it be represented like this. So we can let's say you have matrix here, and where you know this value or you know this value, and you want to know this value, right? That is what is the representation what you want. Okay, so for this kind of representation, like this is slightly different from how we are represented. So let's also assume this way, because n equal to x theta, and then let me try to do something here. Okay, so for making, for in case, like if you can observe, this x is not a square matrix, right? So as x is not a square matrix, you can't do something like x inverse y equal to theta and then do it, because like x is not a square matrix. So only for square matrix, like you can get an inverse, right? So that's why what we will be doing is we will make a square matrix for x. So what we'll do, we'll multiply on both sides with x transpose. Okay, x transpose x theta. So what x transpose x will do is, let us say your x is m cross n. Okay, so your x transpose will be n cross m. So what will happen? X transpose x will be n cross n, right? So this is a square matrix. So for square matrix, you will have inverse as well. So okay, so now what we can do is we can multiply a kind of inverse of these two on both sides. X inverse into x transpose equal to x transpose x inverse into x transpose x theta. Okay, so here what will happen? This is like inverse into that matrix will be identity. So what will happen is this will be x transpose x inverse x transpose y equal to theta. So we got a direct relation x transpose y. So this is direct matrix, right? Like you have x as well, x here. Okay, so you know what is x and you know what is y, and from this you can use this kind of formula and calculate what are the theta values, right? So this is direct kind of computation, like just kind of a matrix, few matrix multiplication and inverse and things, like it is direct equation, right? So we call this as a normal equation. Okay, so where you don't have these kind of iterations calculating the error, and then again like getting the new value of theta here, and for those theta again you manipulate, those kind of things won't be there. It's a direct kind of substitution at this level, where you can get, like for the x what you have and y what you have, you can calculate the theta. But in reality, this won't work well. Why? Because your x, if you take x, let's say 1,000 data, let's take 10,000 data points. Okay, and each x will have x1, x2, so on, xn, x20, let us say. So our x matrix will be this x1, x2, so on, x20. Here we have, like, let's say x1, x1, x2, so on, x20 here, and as well as for the first data point. Similarly, for second data point, you'll have similar things. For data 2 point, you have again x1, x2, so on, x20 for data 2. Similarly, x so on for x. Similarly, x1, x2, so on, x20 for data 1 lakh, right? So data 1 lakh. So for these kind of scenarios, so is it feasible to what we are trying to calculate here? This is only x, right? Your x is of dimension. So x is of dimension 1 lakh into 20. Okay, this is our x dimension. Similarly, you x transpose is 20 into like 1,000. So similarly, you have one more where it is like x transpose x, so which will be like some value, and again for that, so actually it will be reverse, 20 into this one. So where you have this again as like a bigger value here, and for that bigger value, you will be computing an inverse. Okay, so that inverse again multiplying with these things, so it will be very complex. Okay, so it will be so complex like that the computation of your GPU entire RAM, in case if it is a CPU, it will completely occupied with these things. Okay, because like it is a very high computation which it will do, because if it is just inverse of this, inverse itself will take a lot of memory, because like for inverse you also have to calculate the covariance of each at each level, and then also calculate the determinant of it and those things, right? So it will be a very huge computation. Okay, so for such kind of huge computation, you can't if your processing power may not be sufficient in few cases. So if it is sufficient, it will take consume lot of time. Okay, these kind of issues can come up. So because of which we usually don't use this normal equation. Okay, and along with this, one more thing is there are chances where you don't have this inverse as a like a non-zero value. You sometimes the inverse might not exist in case your determinant of this matrix is zero, right? So in that case, you don't have inverse defined. So for such kind of scenarios, you can't use this. So there are few kind of workaround that like you do as kind of pseudo inverse by adding some small values where there are zeros or something like that. But actually, like so we can do it that way. But this is not so feasible technique, because you will be doing very high competition. Okay, so this for this kind of reasons we usually don't use normal equation. Okay, so and in reality the values will be like so huge that we don't even think about this. So this is about normal equation. This is about what we say, like if you understand vectorization, do you have any doubts in vectorization?
No, we don't have any doubts. But my question, Raju,
Hmm.
all this machine itself build these equations, or we need to fetch it?
No, actually, thing is you just have to define how many theta are there, right? Because all these are unknown. It can give like 0, 1, 2, 3, some values, right? A, B, C, something like that. So it can give
Hmm.
automatically like this. So, but initially, if you remember, we have taken all as zeros, right? So just that
Okay.
what it will do is it will try to define a matrix of the shape, right? Like in case if you want only y
Okay.
equal to theta naught plus theta 1 plus theta something like theta 3. So it will only keep a placeholder for four values here, a matrix of like 1 comma 4 or 4 comma 1, something like this. And then the next part is like what it, and similarly this x we have, right? This x is what is there in the data. So it doesn't have to do anything. So next thing is it will do the computations like this. So it is matrix multiplication. So initially we have some values here. So for those values, it will do the multiplication, and it will calculate this error, because we also have this y actual here. So from this, it will do this calculation, and through gradient descent, it will update these values and again do this computation, and again calculate this y e value. So this loop will continue, right? So this is what will happen. So what we'll do is in next class, we'll try to implement this in Python, maybe completely manually. Like there are direct packages available, but for this simple program, we will try to implement it and then see like how, then you'll better know like how exactly it's going to occur. And we'll also try to solve it using normal equation as well, and then we'll see how long it's taking, like, and we'll also see like if there are any problems with it as well. Okay, so